Okay, we are in section 14.6 where we get to apply the sum and difference formulas. If you look here in the boxes to my in green, actually, these are the sum and difference formulas. And let's do this. Corrupt. That's better. So the values that we have here are considered our sum formulas for sine, cosine, tangent, and the formulas here are ways to find the difference formulas for sine, cosine, tangent. The reason why it's useful is sometimes you get the sine, cosine, tangent of a specific value, and it doesn't show up in our special ratios that we were given in our handouts for the unit circle. But if you were to say add two values together, which both of those two values say A or B are on those ratios, we can then solve it by using these formulas here in this chart. So if we look at examples A and B, where it says we want to evaluate the trig expressions using the sum and difference formulas. Well, so example A, it tells us the sine of 7 pi over 12. And for the most part, I usually like to use it in degrees, so I'm going to convert 7 pi over 12 in degrees. So I'm going to try to find the sine of 105 degrees. Now, 105 degrees isn't on the special trig ratios, but I do know that you can take 60 plus 45, and that gives you 105, which 60 and 45 are on the special trig ratios. So let's write this in. I want to find the sine of 60 plus 45. So that means now I can go up, look at my chart, and I can use the sine sum formula to help us solve our trig function. So here, this is going to equal the sine of A, which happens to be 60, times it by the cosine of B, which is 45, plus the cosine of A, which is 60, multiplied by the sine of B, which is 45. So now if I go into my handout with my trig ratios, the sine of 60 ends up being the square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Then I go plus. Cosine of 60 is 1/2. And the sine of 45 is the square root of 2 over 2. So order of operation, multiplication comes first. So this becomes the square root of 6 multiplied by 4 plus the square root of 2 multiplied by 4. I got common denominators, so this is square root of 6 plus the square root of 2 all divided by 4. Okay, let's take a look at example B. So here I have the cosine of 15 degrees. So I could use one of two things. I could take 60 minus 45, which will give you 15, and also 45 minus 30 will give you 15. So you can use either or. So for this instance, I'm going to say let's use the cosine of 60 minus 45. So using the formula, I'm going to say that this is going to equal the cosine of 60 multiplied by the cosine of 45 plus, because it's plus in the formula, sine of 60 multiplied by the cosine of 45. And these are special trig ratios, so cosine of 60 is 1/2 multiplied by the cosine of 45, which is square root of 2 over 2, plus sine of 60 is square root of 3 over 2, multiplied by the cosine of 45, which is the square root of 2 all over 2. Multiply these out. This gives me square root of 2 over 4 plus the square root of 6 over 4. And combine them, it's going to be the square root of 2 plus the square root of 6, all divided by 4. Happens to be the same answer. So if you were to plug into your calculator the sine of 105 and the cosine of 15, you should get the same decimal value for both of those trig functions. Another thing to keep in mind when you're doing problems like this is you may get some negative values. You may get some values that are in different quadrants other than in quadrant 1. So what you have to do is keep this in mind. What I would do is always use the reference angles to help you determine which trig function you're going to use. And then determine if it's sine, cosine, or tangent. Figure out if it's in what quadrant it is, whether if it's going to be positive or negative. If the reference angle for whatever trig function it may be is positive, then you can leave it as is. But if it's going to be negative, then you have to multiply the equation by a negative 1. So, for example, say you were going to try to find the cosine of 165 degrees. Okay? Cosine of 165, if you're going to use this as a reference angle here, drawing it here, this is 165 degrees, but the reference angle of this ends up being 15. So that means for this one here, I would find the cosine of 15, which we did here in example B, which ends up being the square root of 2 plus the square root of 6, all divided by 4. But if you look on your trig or your unit circle worksheet, cosine is negative in quadrant 2. So that means that I would have to multiply this, but this whole answer here by a negative 1. So this would be negative square root of 2 over 2 minus the square root of 6, all divided by 4. So that's where the change comes in. Okay? Next, we get to evaluate different trig function. Say you're given the tangent of a minus b for tan of a equaling negative 7 over 24. It's telling us that it's between pi over 2 and pi. And then tangent of b equals 4 over 5. And they're telling us that b is in between pi and 3 pi over 2. So if I were to draw this on a graph, say for negative 7 over 24, they're telling us that it's in quadrant 2 because it's in between 90 degrees and 180. So that means I could draw a triangle looking like this. And tangent is opposite over adjacent, so I can say that if this is my theta in this case, opposite is 7 because it's going upward in a positive manner, and then adjacent is the negative 24, which is going in the negative x value. For b, it's telling us that it's in quadrant 3 because it's in between 180 to 270, and so that means I get to draw a triangle like this, and that means theta is here, and tangent again is still opposite over adjacent, so this is going to be negative 4, and from here to here is negative 5. And you can find the hypotenuse for other trig functions. So say if you were looking for sine, they could find that out by determining using the Pythagorean theorem. So 24 squared plus 49 gives me 625, and the square root of 625. So that means that in this case the hypotenuse here would be 25, and in this case here my hypotenuse here would be, what, 16 plus 25 equals what? Square root of 41. So that'll help you out when you're determining other ones that are not just tangent, with sine and cosine. So for this particular equation, you're given the tangent of A and you're given the tangent of B. So you get to now plug in these formulas here. So I can say that tan of A minus B, I use the formula, so it's going to be tan A. Well, we know what tan A is. That's negative 7 over 24. So negative 7 over 24 minus tan B, which is 4 over 5, divided by 1 plus, and it's tan A, which is negative 7 over 24, multiplied by tan B, which is 4 over 5. So the first thing I need to do is let's take a look at the numerator, and I'm going to take the negative 7 over 24 and subtract it by 4 over 5, and I get a value of negative 131 over 120 divided by, what I'm going to need to do is do order of operations. So I'm going to take negative 7 over 24 and multiply it by 4 over 5, and that gives me negative 7 over 30. But if I take 1 plus that value, I get 23 over 30. So two fractions divided by, so I can do is I can take a negative 131 over 120, multiply it by its reciprocal, which is 30 over 23. And so here I can take negative 131, multiply it by 30, which gives me a negative 3930 on the top, divided by 120 multiplied by 23, which gives me 2760. And so negative 390 divided by 2760 gives me negative 131 over 92. And that's simplified. Next thing we get to do is we can simplify the expression by using the sum and difference theorem. So from here, I can say, well, actually what I want to do is I'm going to convert this to degrees. So 5 pi over 2 ends up being 450 degrees. So I can use the formula to help me out. So I can go sine of x times it by the cosine of 450 minus cosine of x times it by the sine of 450. So if I look at this here, cosine of 450 will give me 0. So anything multiplied by 0 is going to give me 0. So I got minus, and then the sine of 450 here is 1. So cosine times by 1 gives me the cosine of x. So 0 minus cosine of x gives me a simplified form of the cosine of x. Okay? Last thing in this section deals with solving trig equations. And then for this case, our parameters are between 0 and 2 pi. So for A, I have the cosine of x plus pi plus the cosine of x minus pi. Again, I like to use degrees, so I'm going to go cosine of x plus 180 plus cosine of x minus 180 equals 0. So now I get to use the sum and difference formula for cosine 2 times. So if I go look at this one specifically, I'm going to rewrite it as cosine of x times it by the cosine of 180 minus sine of x multiplied by the sine of 180. There's a plus in between there, so now I'm going to go parentheses, and now I have the cosine of x minus pi, so now I'm going to incorporate that formula, so the difference formula, so it's going to be the cosine of x multiplied by the cosine of 180 degrees plus sine of x multiplied by the sine of 180, sorry. So here, if I take each one individually here, cosine of 180 gives me negative 1. So negative 1 multiplied by, so that's going to be what, negative cosine x for the first part. And then the sine of 180 degrees gives me 0. So this cancels out. So now I'm here, and now I go plus. Now I look at this one, and then again the cosine of 180 was negative 1, so this becomes negative cosine x. And then the sine of 180 was 0, so this cancels out. So now I'm just left with negative cosine x plus negative cosine x equals 0. I combine like terms, so this is like 1, negative 1 cosine x plus negative 1 cosine x, so this is going to be negative 2 cosine x equals 0. So now I get to put this by itself, divide both sides by negative 2, so now I'm left with the cosine of x equaling 0. So now in order to find x, I must just take the inverse of 0, which ends up equaling 90 degrees, and it was in radians, so it's going to be pi over 2. But if I were to take, there's another value that's also going to equal 0. It's also going to be 270 degrees, and that is also 3 pi over 2. Okay? And that is being able to apply the sum and difference pattern. Hope this helps. Till next time.